All right.
Cool. So I assume this is all visible.
Yep, all good.
Thank you. So as you mentioned, we're talking about deploying Terraform Enterprise in a highly secure environment at Morgan Stanley. And I'm going to be presenting. I'm a VP in the AWS engineering group in Morgan Stanley. And Travis Smith, my co-presenter, is also a part of this group as well. Cool. So let's start with Morgan Stanley in the cloud, right? What are we doing in the cloud? Lots of text, right? I'm not gonna both straight out read this slide. We, like other financials, are accelerating adoption of public cloud. Public cloud is great for us. We love the features like elastic capacity and all the innovative platforms and solutions that the cloud gives us. And there's a lot of demand internally from our development groups and from our customers to use and leverage more public cloud. But to do that in scale, we need infrastructure as code. Otherwise, if you do things by hand, that's not a good recipe for success. So we've chosen to adopt Terraform, initially the open source, and then moving on to Terraform Enterprise to give a little oomph to our deployment platform to make sure we scale to our user and engineers' demands. Terraform Enterprise, as I said, is a great tool to do these things, but our ecosystem, our environment as a financial services company is a little challenging because we have a lot of strict regulations and security guidelines that we have to comply by. So there's some design hurdles in how you deploy and install Terraform Enterprise. And this is basically what we're here to talk about, how we solve some of these problems, why we solve some of these problems. So if you have the same problems, you can solve them as well. So before we start with how we solve things, why did we solve things? Why did we install Terraform Enterprise? Why deploy it at all? So Terraform Enterprise comes with lots of great features. As I said, we are very interested in policy as code. It solves a lot of problems for us if during the deployment pipeline of infrastructure, you find problems, right? Fail fast. If something is wrong, something is out of policy, it's better to resolve before you deploy. So you won't have to remediate it later. And in Terraform Enterprise, that feature is Sentinel. Team collaboration. We have a lot of teams working in the cloud together. For that, we want to share workspaces. Something's a little more complicated in the open source Terraform. Multi-layer deployment, same story, several different teams. In our story, there's affinity between the different teams. If team A built something, team B might need to build something. So we chose to leverage run triggers for that. So one deployment can be triggered from an additional second deployment. Reusable blueprints. We learned quickly that if you do something right one time, you want to do it right again and again and again. So patterns are reusable, and you should do that. You should use them over and over again. The feature we're looking at here is the private modules registry. Modules are the way you do a pattern in Terraform, and the registry allows us to share our patterns easily internally. And lots of other bells and whistles around deployment workflows, cost estimations, better auditability than using the open source, and obviously the built-in RBAC, which is great for us. So I talked about security requirements, right? Very strict. We have to build something. Usually when you put a bunch of restrictions on something, you will lose some of the value, right? If you secure something, it lock a part of it away. We had to make sure that we're not doing it, or if we are doing it, we know what we're settling on here. So one thing we couldn't settle on here is user friendliness. If we were to change how some things happen in Terraform Enterprise to add security, we could not make the deployment process hard for our app dev teams, because otherwise they would not want to do the right thing. You have to make it easy to do the right thing. Resiliency, our solution should obviously not crash, right? Scalability, it has to scale for many users and many dev teams at the same time, because if there's a pipeline, you can only one person can deploy at a time, that's not really doing cloud at scale, right? This is more on the security side of things. We have to make sure our credentials and identity is safe at all times. Terraform and deploying with Terraform, you basically give Terraform the keys to the kingdom, because you deployed the infrastructure with these credentials, you can destroy it with these credentials usually, and we definitely do not want that. A secure SDLC, it says secure, but it's more about securing the process and less about security. We have to make sure that when users develop infrastructure with Terraform, they do it the right way, with the right workflow in the SDLC perspective, meaning they can't push their code directly from their workspace to Terraform, and then we don't have the most up-to-date code in the repo, or that they deployed the wrong environment. They have to do it the right way. Okay, so let's talk about some of these challenges a little more. Let's zoom into them. I'm going to be talking about a lot of these challenges, and then we'll see how we solved each and every one of them. I'll talk about the challenges and the problems, and Travis, the solutions, because Travis solves things and I bring out challenges. Basically, the first problem that we had with SDLC is that our SCM tool, our source control tool, is a SaaS tool. Terraform Enterprise, we installed internally in our environment in a private subnet that's not reachable. Problem, right? The way Terraform Enterprise works, is that you need, for it to trigger a build, you need to connect it to a webhook callback from the SCM tool. So that was kind of something we had to solve. And another thing I mentioned earlier, right? We want to make sure that users are not doing the wrong thing by pushing code to the wrong workspace or pushing code from their environment. We had to make sure that they cannot do that. So that was another challenge. And here's a diagram of somebody doing the wrong thing, right? There's a local repo, the bottom left, with credentials to Terraform Enterprise. The user, through a proxy, because everything happens through a proxy, goes and pushes their code directly to a workspace in Terraform Enterprise. And this, like, it ticks some of the boxes. It's very user-friendly. You just Terraform apply, right? Magic. Very resilient, very scalable. There's no way this can crash, and you can scale. You could do this for as many users as you want. But our credentials are saved locally somewhere, which is not good. And this is not right on the SDLC perspective, because it's not the way to do things. More challenges. Networking. We, like, I would say, most regulated or highly secure aware industries, any access to the internet has to go through a proxy that's auditable, right? Everything you do gets registered somewhere to a log to make sure that if somebody do something bad, you can track and see what happened. So that's one challenge we had to figure out, the internet access, because Terraform does need internet access to fetch some resources. And second thing, as I mentioned this earlier, you need inbound access for Terraform Enterprise for it to trigger the builds. I already mentioned this before in a different perspective, but it's also a networking problem for us. Credentials, this is a big one. And because it's so big, I'm gonna transfer the baton to Travis. Travis, do you want to take this?
Yep, sounds great. Let me share my screen out here. All right, so like Itay touched on there a couple of times, credentials is obviously going to be a big one for us. For most people, credentials is a problem. It's definitely a consideration to make during the evaluation of your architecture or your application. So we wanted to make sure we went through all the different scenarios, picked the right credential model, and implemented that as securely as possible. So we want to make sure we can have temporary credentials, make sure that we're not storing things too long or allowing things to be accessed by people who shouldn't have access. So the first one is the obvious first case is static credentials. I think we all know by now that this is usually not the greatest of answers when avoidable. So this is where we would just generate credentials in our target account and store them in our workspace as a workspace variable. And then from there, Terraform will just pick those up in the environment. Obviously, this is fairly user friendly. The user doesn't have to do anything. It's fairly resilient. The credentials, we rely on the AWS APIs at that point. It scales, so we can generate these credentials when we deploy our application or when we deploy our new workspace. But at the end of the day, it's not very secure. So those credentials live a long time. They're there. They're not being rotated. They don't expire. If they are ever exfiltrated, they would be usable from then on. So, and as Itay mentioned, these are pretty privileged credentials, so we don't want those getting out there. Okay, so our next case was maybe we could do it during our CI/CD pipeline. So maybe as part of the pipeline, we generate credentials. We have a build host that pushes the credentials into Terraform Enterprise. Again, this is fairly user-friendly. The user doesn't have to do a whole lot. Somewhat resilient. You're relying on a single build host, but at the same time, it's pretty standard part of the practice. It scales. You've only got one build host. It's able to assume roles. But again, we're not really secure here. So rather than have somewhere that the user can't get to, we're using a build host. So this is part of their pipeline. They have full access. They could echo their credentials out at any time if they wanted to, or interject other malicious code, or just implement that incorrectly. So again, this is not going to be the greatest of cases for us. Third option is just create an instance profile. This one seems like the most logical and obvious, easy case. We create an instance profile. We attach it to the EC2 instance. After that, we can assume roles using our providers. We can assume roles into any of our accounts. So again, pretty straightforward, extremely user-friendly. They just have to create the provider. Resilient. If the TFE workspace is running, it will run. It will scale. So at this, we're all relying on the AWS APIs again. But again, we have the problem of security. So we have a single instance running on EC2 that has keys to all of our accounts. They can assume role into any other account in our environment and do whatever they would like in those. So we had some concerns around that one as well. And then finally, we discussed doing the credential generation on the build host and having a separate build host for each of the applications. So by doing this, we have separation of credentials. Users can't get into each other's accounts. But this one obviously becomes kind of a scalability issue, as every work stream or every app team is going to need their own build host. So we wanted to try to come up with something a little better than that as well. So let's jump into our solution. Couple of diagrams here. So first, I'll just kind of go through this. We've kind of got our internal networks and our VCS off to the left, our target accounts, the account we're trying to apply our Terraform to on the right. And then we have our development account or our deployment account here in the middle. And so our solution takes kind of the core pieces of TFE using the API, and does a little bit extra on top of that, takes security into account for some of the controls we need, and then deploys that. So I'll step through it here one at a time. The first thing, so we talked about not having incoming network access. So rather than have incoming network access, we're going to make all of our network access outbound. So our CI/CD build hosts are going to reach out through our proxies, all that being logged, like Itay said, talk to our VCS and see if we've got any new code to work on. Once that code is found and we see that we have a merge or a PR, we'll pull that code down and we'll do something with it. So step two, we've gotten new code. We know that new code exists out there in our repo. We're going to trigger an API internal to us. So we're going to tell that API, I want to trigger this particular workspace with this particular commit. Will you cause that to happen? So that's going to call out to Lambda, and Lambda is going to do just that. So Lambda is going to check the workspace that we're talking to. It's going to pull down some information that it needs. So it's going to find the repo. It's going to make sure that it's the right repo for the workspace, that the commit exists there. And then it's going to do a little bit more with that. So step four, it will take the information that it found in the metadata that we stored in the workspace variables. In particular, it's going to take the account number and it's going to use that to assume the role. So in this case, we've got Lambda assuming the role rather than a build host or any particular user. When we do that, we generate our temporary credentials. We hold on to those. Here in a second, we'll use them and push them into the workspace. Step 5, we reach out to the VCS, and again, we pull down that commit. So this is our way of ensuring that the code we're deploying is checked in code, that it's following proper SDLC practices, and that the users aren't trying to intentionally or accidentally subvert our processes. So we're reaching out to the VCS. We're saying, can you give us this commit in this repo? As long as that commit exists, we'll pull it back in and we'll bundle it up. And then using the TFE API, we'll push all of this data into the Terraform workspace. So we'll push the credentials into the variables, and then we'll create a new CV on the actual workspace and start a run. So for things like PRs, for pull requests, we can do a temporary run. For things like merges, we would do the full run. So rather than actually do the speculative run, that's the word I was after, we'll do a full run and actually deploy the code and still be able to use all of the approval processes, the state file storage and all of the good features that we want in Terraform to start with. So let's talk about how we solved each of those problems just a little more in detail. The first one, we don't have any inbound access. So again, our build hosts are reaching out to our VCS rather than our VCS reaching into our Terraform Enterprise. So we don't have to worry about any kind of inbound network access. And all of our outbound access, we'll talk about that on the next slide, I believe. So code, again, we're being really strict with our SDLC processes. So we're not allowing people to subvert that. They must only deploy code that goes through the VCS. In order to deploy code and run a non-speculative run, you have to have code merged into your main branch. And then again, PRs, any activities will trigger the pipeline so that you can see speculative runs and get feedback on any code that you've deployed. Again, I mentioned network before, but all of our traffic becomes egress. We're going out either via our VPC endpoints, so talking to the AWS APIs, or via our proxy. So we're able to go out via that and log all of that traffic. Inbound access, again, we're in a private subnet. We don't need any inbound traffic. All of our traffic is limited to either a local API gateway or to the build host that, again, is reaching out through the proxy. And again, so for credentials, we covered all of our high points here. We don't have any long-term credentials. All of those are assumed through STS. So they're temporary. They'll likely have a short lifetime of maybe an hour so that the deployment has time to run. But that the credentials, even if they were ever used incorrectly, wouldn't live very long. So we're taking away the ability for the user to or any user to be able to get access to the assume role. The users can't log on to any instance that has an instance profile. They can't log into TFE and get the assume role. They're strictly required to run it through the Lambda, and only Lambda can assume that role. And our Lambda has more security around that so that it can verify that anybody who calls the Lambda is calling it with the correct parameters, making sure that the commit and the workspace line up, that it's actually part of a repo that's assigned to that workspace. And again, credentials are never exposed to users. So the user never gets the chance to echo out a variable and be able to see those credentials and plug that into their local file and run Terraform locally. Obviously, as we scale, we have to keep things like that in mind. Just as people look for ways to get work done, it can come up. It may not be malicious, but we do have to keep that in mind as we scale out. All right, and I will pass it back over to Itay and let him kind of wrap us up here.
Thank you, Travis. Let me share my screen again. Perfect. So in summary, as we said, Terraform Enterprise is a solid platform for infrastructure as code, in our opinion. But there are some design difficulties when you do it in an environment as secure as ours. There's some things you have to keep an eye out for. Using cloud-native solutions, we overcame these problems, meaning you can as well, right? Everything we're doing here can be redone for anybody else. And they can leverage then Terraform Enterprise in a secure environment. So what's next, right? We solved all the problems. So we're looking at Terraform Cloud for Business. It's a new Terraform Cloud business tier. Basically, Terraform Cloud plus additional security restrictions and guidelines, which help us. So if Terraform Cloud for Business solves our credentials problem, it looks like it does, we will be able to solve some of our networking problems as well. Terraform Cloud and our VCS provider, as we said, are both SaaS tools, meaning they won't have to interact with each other through our proxies or ingress, or very easy, right? They're both in the cloud. They can just cloudly talk to each other. Solves that problem for us. Credential generation solution that we detailed earlier with the Lambda is reusable. We could generate our short-term privs, and we do things that way. And luckily for us, Terraform Cloud for Business and Terraform Enterprise is the same APIs. It's the same product, just in a different managed fashion. So our solution of pushing the code version, the workspace code version that Travis showed a minute ago, would still be usable. It's fully compatible. So we could leverage the same solution that we build and still keep the level of security that we have while not having to maintain the infrastructure and solving another problem that we have with networking. And that's it. Thank you so much.